can speak to it.
Yeah. I kind of wanted to start this specific session or intro with different kind of programming languages that are out there. If Ruby is your first programming language, we've also you also might have seen JavaScript before if you worked on the JavaScript track for the pre-work. However, when we introduce SQLite or SQL, SQLite is just a lighter version of SQL. It's a database query language, and on top of that, it is also a declarative language. So if I'll look up declarative like programming languages. Ooh, it's already being a little slow. Please survive with me. But there's two different kind of programming languages that are out there, and object-oriented programming or Ruby is imperative. And what we mean by that is I have our past code that we've written. We're back into hike land. For example, writing out a method, trying to figure out like what kind of methods we wrote, but something like, hey, I want to find the mountain. What am I going to do for that? We would have to write the code and write the algorithm to figure out what class do I need to talk to, what class do I need to reference in order to satisfy this specific method. And that's what we've been doing since day one in Ruby. However, when we're working with declarative programming languages, and you'll be working with React and Mod4, which is also a declarative framework that we'll be using. But what this says is I am going to tell you what I want and how it should be formatted. And technically as devs, we don't have control over how SQL runs that query or how SQL talks to the table in a sense to get that data. All we care about is the data that comes back. For example, you probably have some experiences like looking at tables and seeing some data inside of there, rows and columns. What SQL says is, tell me what you want and I will go get that data for you, but you are not controlling the language or the algorithm behind that. So that's how declarative programming languages are. And in a sense, it's very different because you don't have a lot of control. However, it can also be very liberating because all you need to know is recognize some of the syntax and how you need to write the query, and that's it. And you'll be able to get the data back. So it's super cool. It will take some time for you to kind of get used to it. What I want to kind of go over at a high level for this week, though, is we are not going to be spending too much time with SQL. So that's what I kind of want to enunciate in the beginning. We are going to introduce databases, and eventually by the end of this week, we're going to be introducing a framework that will communicate with the databases for us. And as you might have noticed, SQL can get super complicated, and you can have like nested queries on top of queries. And if we had to do all of that for our programs, it's going to take a long time to even just query a database and get the data that we want. So keep in mind, you do not have to become a SQL expert to work with databases. So the goal is not to get like super awesome at SQL. The goal is to recognize patterns and get comfortable with basic functionality that's available to us with SQL so that we can apply it in different frameworks that we're going to use. And that's typically what you're going to see in the industry too, when you start building out websites and when you start building out databases in your backend. Unless you're actually creating a database with your team, no one's going to expect you to know every single SQL query out there. I forget a SQL query all the time, so you'll even see me look it up here, but I want to give you a heads up on that. Any questions so far? All right, so I'm going back to the model that we've sort of created together, our many-to-many relationship with our hike being our join, so that you can kind of see something that you've already seen for a model, and then we'll take it and see how we can represent that inside of our database here. So I'll go over what's in here in a little bit, but this is what we have so far. We have a many-to-many relationship that we've defined in our Ruby program, and we say that a hike belongs to a mountain and a hike belongs to a person. And because hike belongs to both of these objects, it's storing the mountain instance and it's storing the person instance inside of itself. And we also have our add at all and all of that information that's keeping track of every single instance of a person, hike, and mountain that's been created. So this is what our many-to-many relationship looks like right now. And tomorrow we'll be kind of taking a look at our database and seeing how we can connect that with our Ruby domain that we've created here, which will be very nice because you'll be able to work with tons of data on top of what we have. For today, our SQL introduction is going to be completely separate from Ruby. So our goal for today is SQL, and tomorrow we'll kind of integrate it with Ruby. Just want to give a notice there. Cool. So I'm gonna I added this in the README too, so you'll have access to this. But I want to go over a general introduction to what a database is going to look like. And then we'll kind of start talking about why we even need databases, why do they exist, and we'll get to implement some queries that we should get comfortable with in SQL. There's only really like 4 basic queries that you need to know, and everything else you don't have to really worry about like memorizing or understanding. I loved Scott's reference to that SQL cheat sheet. Great document to kind of just get a high level view of all the queries that are out there so you can kind of see everything in one page. So cheat sheets like that are super helpful to at least get comfortable with syntax before you implement it. Sweet. So before, if we take a look at just a sample SQL database, I have some data that I pre-filled that we'll be using to associate or that we will be using inside of here. So this is just sample data, and we'll get practice kind of creating them in our database. But when we talk about our SQL database and its creation, right now I have 3 different tables that we've added. We have a people table, we have a mountains table, and a hikes table. And I intentionally named this people because what you'll notice about the convention for our table names, it's storing many different instances, or it's storing many different rows of that one type. So your table names are always going to be plural. And you'll kind of get used to this convention as you create your own tables, but that's something to keep in mind. So right now I have 3 different tables, and I don't know why there's a 4 here, but let me change it to ID. And there's some main components that are always going to be the same or always going to be present inside of a basic table when we look at databases. So it's always going to have an ID associated with it, and this is going to be the primary key ID for our table and our rows. So every single table is going to have its own ID associated with it. And every single table is going to have its own set of columns associated with it. And we'll deep dive into this tomorrow on why. And every single table is going to have a bunch of rows. And each row is going to represent a certain data point that we can reference. What I want you to get comfortable seeing right now, right off the bat, is how we talk about relationships inside of a database. And if this feels a little weird right now, it's okay. But I want to introduce the idea that before, when we have a joined class or when we have a class that belongs to another class, we store that whole object ID. And I want to introduce the idea of storing a reference or storing a foreign key. So I'll kind of review and define this. In databases, these primary key IDs and these foreign key IDs, which is what we're seeing in this column and these columns, becomes super important because these are how tables get connected and how relationships get connected. So when you're starting to think about relationships and tables and how do they connect together inside of a database, that's how we're going to reference them. And you'll kind of see a pattern here. If I see a mountain ID of 4 for that specific hike, and I see a person ID, then it typically means the person with the ID of 4, which in this case is Ahmed, hiked, person with ID of 1, Jisandaria, hiked mountain ID 4. Oh no, which is the couch. I think I saw this on the Slack channel. Someone said like, person not new couch or something, which was hilarious. So that's why I added it here. But I hiked to the couch and that's that person. But you can kind of see the relationship between the primary key and the foreign key. The foreign key is always going to map to a primary key in a different table. I'm gonna pause for questions.
And then for the foreign key, which is the mountain key in the person ID key and the hikes table, you're manually, you're assigning that, right?
Exactly. Yep. These are values, and I kind of put it in the visual here. We'll see it when we create our table too. But yeah, these are values that I put in myself. I said 4 and 1 and assigned it as a new row.
And these are not places in memory like we were previously doing with in OO. So they're literally, it's the actual ID of 1 for person ID. And that will then SQL somehow magically knows to get the actual ID of integer of 1 in the appropriate table.
Yes, that is true. And we'll actually be, once you get comfortable with SQL, you'll get to see what the correlation between matching up the IDs is going to be when you have 2 different tables talk to each other. Yeah, those are good questions.
So the foreign key is, in this case, the reference to mountain ID and person ID in the hikes table, which Perdita has many through, like hikes has references to people in mountains, but the mountains would only have references to people through the person ID of the hike associated with. Okay, I got it.
Okay, I lost you
Wow.
for a little bit there, but I'll say
But
this.
it's essentially, it looks like it's the same structure as like a has many through
Yes.
relationship, where like the mountains table could, but it's not the same because it's in SQL and it's not object oriented. But the foreign key is mountain ID and person ID.
Yes, that's where the foundation of object-oriented design that we've been doing with the has many and belongs to, the relationship is exactly the same. The way that it's represented is a little bit different. Yep. So you're still seeing a has many through relationship in our database. And we know it's that relationship because of the reference keys that we set up, this mountain ID and person ID. And you'll kind of get used to the convention of what this needs to be, what a reference key or foreign key needs to be over the next couple of days too.
Awesome. Okay, thank you.
All right. Yeah. Sweet. Any other questions? Awesome. So this is just an example of a sample table data that we can look at inside of our database. You're typically going to see this like cylinder structure, potentially in like UML diagrams to represent a database. So whenever I talk about a database or I visualize it, I'll intentionally use this cylinder here. And when you see people, mountains, and hikes inside of it, I'm just saying this is our database. It has 3 different tables called people, mountain, and hikes. And then you can kind of like deep dive into that and see what actual data is inside of there. Sweet. Let me go to VS Code. So I'm going to ignore this for today. I kind of just wanted to build it off of this project. This should be pretty familiar to what we've been doing so far. I'm going to create a SQL database from scratch so that you can get comfortable with using SQLite inside of your project. And I wanted to introduce a couple different tools that you can use to view your database, and a couple different tools that are available to make it a, yeah, there will be 2 different tools, but to view your database, to run queries, that might be slightly easier than running SQLite inside of your terminal and trying to process those commands. So we usually recommend this external tool. One of the labs also walks you through downloading it. Go. Okay, never mind. It's called SQLite Browser.
What do you mean by, what is define query, like running a query?
Yeah, so in this case, whenever we create a query, it's the query that is basically our SQL query, and it's going to talk to the database, figure out what table it needs to reference, and give us some data back. So that actual query that we write, for example, here, it's a create table, but something like select everything from our mountains table, that is the query itself.
Gotcha, thank you.
Yeah. SQLite Browser. So that's the one that I want to introduce. I already have it installed, but it's linked in the README. SQLite Browser is another tool that's available to you to open your database and see what tables are there and all of the rows and columns. If you're a very visual person, then it's easier to kind of visually see all the data there, which might always not be easy to see on the terminal side. And I also have an extension, which I do not have open. If you search SQLite inside of your VS Code. It should be this one that shows up first. And this is another extension that you can install to view your database. I'll kind of show you how to use it after we create our nature database for our mountains. However, if you want to, you can also download this extension for VS Code. Very similar to SQLite browser, you can open the database and take a look at all the columns and rows that are there. And if you ever have issues installing this or anything like that, let us know. You can debug later.
I'm actually getting issues. I just tried downloading it saying that the software needs to be updated and my computer will not install it because of that.
What? Okay, well, that's fun. If you can't do the update, then try to look for another extension that you can potentially use if you want to use it inside of VS Code. I also recommend SQLite browser. And I've been using SQLite browser as my main. Is this not letting me?
That's exactly what I'm getting.
Okay, I have to take a look at this. I'll debug this on my end and see why it's not able to open it. That's weird. No, I might have to reinstall it. Never mind. Let me exit out of this. I'll debug this and fix it. And Scott, I'll tell you what the fix was. Da-da-da. All right, well, typically I use SQLite browser. For this one, I was going to use the SQLite gem in the terminal anyways, so I think it kind of works out. I'll set up the SQLite browser stuff and kind of show you how to visualize tables from there too. Inside of our, in our README, to kind of transition, you got an example to see an example of what a database can look like. What are the different parts that make up a database? What does a table look like with the rows and the columns? Now I kind of want to have a discussion of why we need databases at all. When we talk about databases, what are your thoughts, or what's the first thing that comes to mind? And this is kind of just brainstorming ideas. There's no like right or wrong answer.
Huge swaths of data.
Did you say lots of data?
Yeah.
Lots of data. Yeah.
The ability to find hidden connections and references, patterns.
Ooh. Connections and references and patterns.
It's safer in case something gets deleted.
Safer in case something gets deleted.
Have data persist between sessions of a program being run?
Persist between sessions of a program being run. Yeah. Love it. What else?
And it's all stored in one space, making it convenient.
Yes. Stored in one place. Very convenient.
The future.
The future. The future. Yes.
You can't have big data without databases of some type.
Big data. I almost put big data. You can also big data. It's a whole separate like world. Big data is great. All right, what else? The future. I love it. Sweet. I love this list. You all kind of encompassed why we need databases. Definitely lots of data. You'll see right now what we do in our measly little console file. We got some hikes we create, some people, but you can store scores of more data, loads of more data inside of a database itself. I like being able to, I like this finding connections and references and patterns. When you start storing relationships or adding in those foreign keys and references inside of the database itself, it can become super powerful because you now have a way to store relationships on the database side, and you don't have to handle that workload inside of your Ruby project or inside of your app. When we talk about getting into like back-end and front-end development, dealing with all of the operational stuff that you need to do on the database side or the back-end side is going to make your app more functional, and it's going to make your app more performant and more efficient. Things get corrupted and deleted all the time in the industry, and if you didn't have backup and if you didn't have a way to keep track of different versions, it is going to be a pain. So as you know, like with GitHub, we have version control, same thing with data. You need ways to store it and you need ways to recover it if it does get corrupted. Persistence is super important. And I would say like this is one of the first distinctions that you'll see for us creating a database and storing that data. Right now, when we run our Ruby program, after I exit out of that pry or after I exit out of that console, all of this data is gone. I don't have access to it. I need to rerun the program to recreate this data and store that in memory, which is going to become super inconvenient if I actually want to use this data somewhere else. And that's where the idea of persistence and being able to store all of that information in one place becomes amazing. On top of the future, which I love, and big data, I also want to add with databases, you now have a way to very conveniently pass around information so that multiple people can work on it at the same time. So I can take my SQL database and I can send it to someone who's in like another country, potentially, and have them access the data that I'm using. And I don't have to have them recreate or rerun the program. So I'm going to say, makes sharing data easier. Cool. Yeah, I was going to say something, but I lost my train of thought. So we will move onwards. Any other questions or people want to add on why we need databases? All right. And there's lots of types of databases out there. In the world of Flatiron School, we'll be looking into SQLite databases, and potentially when you transition into Mod 3 and Mod 4, you'll be using a Postgres database, which is also another version of a SQLite database. The reason that we introduced SQLite versus all the other databases out there is because it's very lightweight and you can kind of, it's all represented in one main file, which is what you've noticed in the lab so far. Our database is literally just one SQLite file called DB, and you can package all of that data inside of that file itself, which is very powerful. And it's kind of cool that we can kind of just create one and have that data accessible there right away. So that's kind of the reason that we start with. What you'll notice about SQL versus SQLite, the convention is going to be pretty similar, but there will be some things that you can do in a basic SQL query that you are not going to be able to do in a SQLite query. So I would just get comfortable testing things out. Queries that you might see on the internet, maybe on Stack Overflow, you look something up and you're like, yeah, this should work. And you try it and it doesn't work. It might just be that SQLite doesn't support it. So pay attention to what version of SQLite or whether you're using SQLite or SQL when you're trying to run those queries within your program itself.
If it doesn't support it, will it kind of let us know, or will it just have like a generic like undefined answer?
It's gonna have that generic undefined answer. So it should just be like, I don't recognize this query. Or the infamous SQLite error, I think, is it just says like syntax error near, and it'll process as much as it can, and it'll be like, I don't know what to do from here. So anytime you see that, and you know that the query itself is correct, it probably means that SQLite doesn't support that query. Yeah, it's a good question. Sweet. Cool. So that's the why behind like databases, why we're using SQLite. Anything else people want to talk about before we create stuff? All right. To get us comfortable with seeing the terminal and running stuff inside of there, I'm going to open my terminal and run SQLite inside. The SQLite 3 gem, if you remember, deploy on day 1, you installed it during that time. So that's where this gem comes from. So all of you should have access to SQLite 3 inside of your computer already. And this is a gem that allows us to communicate with our database. It will open our database up, make it readable inside of our terminal. And sort of what you were seeing in the beginning, if you're ever running any SQL queries on that specific database, this is the format that we'll use. So what's actually happening here is you're taking the SQL file, which the SQL extension indicates that this is going to be a SQLite query code. You're going to take this file and you're running it against the database itself, which is nature.db in this case. And it's going to run that query and store it inside of the database and store that change. So that's what's happening here. And we'll kind of get practice doing this with our SQLite queries. So first step, our project is empty. Well, no database is created yet. So I'm going to create the database. And the command that we're going to use for that is the SQLite 3. I'm going to call our app nature, or our database nature, because we're in hike land right now. And right away, if your query was successful, you're going to see the SQLite query here. The first thing I want to introduce, which you should get into the habit of doing whenever you open up a database, is check out its schema. You might have noticed like the schema keyword so far in your program. What schema stands for is it tells us a high-level view of what your database has in terms of its tables, in terms of its columns. It's not going to show you any data, but it's going to give you information about the database structure. So database structure and schema, they mean the same thing, and you'll see me use them interchangeably back and forth. So if you're like, wait, what does that mean? Schema, database structure, same thing. And schema is going to tell us what the table and columns in our database are. So right now, I just created this database. So if I say .schema from here, I'm going to get nothing because there's nothing inside of my database right now. And I'm going to try and go back and forth and type in this information here. No. Okay, well, I wanted to. I'm going to do it in the README because this program is not being helpful right now. All right. So I'll add these in notes and then you can have them for reference during your like lesson reviews. So schema is going to give us high-level overview of the table and rows for our DB. So get into the habit of checking the schema first thing. Anytime you make a change, check the schema. Anytime you open up a completely new database, check the schema. And you'll notice as soon as I ran that SQLite command inside of my project, I now have the nature.db. If you view it in your VS Code, it's going to be gibberish because you're not going to be able to, VS Code is not going to be able to encode that data. However, either through SQLite browser, once I fix my bug, or through the terminal, you'll be able to kind of see the data inside of it. Any questions on that? All right. I'm going to go through some examples of creating a table so you can see what it looks like. And I'm going to create all of my tables inside of the terminal itself. And we'll take it from there. So in the beginning, I have like a create table command that I'll just copy paste here. So if you want to create a table inside of your database, you're going to use the create table command in SQL. And the first part is the table name. And then you're going to specify all the values that it needs, or all the columns that it needs, and the data type. So we're going to say integer primary key and name text. You might have also seen this other field that I add here called auto increment. Let's see if I spelled that right. And what this will do is this will allow SQLite to take a look at all the IDs that have been there so far, and it'll increment +1 automatically inside of your table. So this way you don't have to worry about setting a primary key ID. It's a little bit more automatic. What you'll notice once you start building out your database, SQLite has its own set of tables that it'll automatically create on the back end, which it will use to manage the primary keys that it creates, the amount of rows. So it'll kind of keep stats on what your database looks like. So that's why you typically don't mess with ID. Keep it whatever the primary key the database gives it, because SQLite is using that in the backend. All right. And this is typically where the beginning woes of semicolon begins. So now you get to worry about making sure that your queries end in a semicolon. Anytime you type in a query and you see this like ... greater than sign, what it typically means is SQLite is waiting for this query to be over. So typically you need to end that query or just put in a semicolon. All right, and then let's check schema again. So now we created our table, which is awesome. And because I put in this auto increment, SQLite also has the SQLite sequence. And this will take a look at the amount of rows that are in the table, and it'll do the auto increment from that. Super awesome. Cool.
You don't auto increment, the ID, you'll need to do that yourself.
Typically, if it's a primary key, it should automatically increment the next one anyways. I'll remove this for the second one and we'll see what happens. So
Yep.
the primary key should automatically increment either way. This allows it so that it creates that table, and if we end up like accidentally deleting a row, then it still preserves that ID. So it'll behave a little bit differently, but ideally integer primary keys should be sufficient for your primary keys.
What is the second row of create table was again?
Yeah, this is the SQLite sequence. It's something that's automatically generated on SQL side to manage your primary keys and manage the rows in your table. So you'll never
So
be modifying that. SQLite on the back end will reference it.
But I have to type it every time.
Type what? This?
Yeah.
For this one, this is something that's automatically there. You won't even have to pay attention to
Okay.
it. So this was automatically generated for us. You'll never have to create this.
Okay.
Yeah. Cool. But if you ever see it, there's a couple other ones that'll get created. If you notice like extra tables that show up that you didn't create, SQLite's doing that for you on the back end. Cool. Yeah. All right. Let's create some people. People's a little weird of a word because that's the plural of a person, which is why I named it people. But the main part is name your table names to be plural. That's the main convention that you need to follow when you're creating your tables. The table name is always plural. All right, dang it. Yeah, thought I forgot the semicolon, but it's there. Sweet. So I'm gonna add that as a note in here. Where did my collection of notes? Oh, it's right here. So terminology. Notes. Oops. For table, I wanted to add table names are always plural. All right. Now let's create some rows. So I'm gonna clear this out on the Mac. If you want to clear a screen, because SQLite doesn't have like a clear command, if you hit Command K, it'll clear out the screen so you can start afresh. Let's check out our schema again. I'm gonna overdo this so that we get into the habit of it. But we got 3 tables now, and let's say I want to create a new person. So who wants to volunteer navigating me through creating a new person inside of my table, if you know the SQL query for that?
I think I could do it.
All right, thank you, Daniel. Let's do it.
So we're doing people.
Yes.
Okay. So insert into people, and then parentheses, name, and then capital values, and then do Daniel in parentheses.
Awesome, and then semicolon.
Yeah.
Sweet. Oh no, that's fine. And when you're navigating, for whoever wants to volunteer, feel free to look up the SQL query. I don't mind if you're like looking this up too. That's totally fine. Cool, awesome. So insert into. You'll notice it's a pretty similar structure to our create table. We put in our SQL operation that we're trying to do, the table name, the columns that we want to add to. Order does matter because SQL is going to put in these values directly one-to-one, similar to our Ruby methods, arguments versus parameters, and the value Daniel.
Do the values matter in terms of the table design, or only related here where you have insert in the people name, values is Daniel?
Yeah, that's a good question. Only related to here, because sometimes you'll just want to put in maybe a value for one column and not the other, and you want to be able to control that. You'll set boundaries for your table where you'll say this parameter needs to be there. It can't be null. So you'll be able to kind of control that a little bit. But initially, by default, if you want it to be null, you want the user to be able to put data inside of there and not worry about it automatically being rejected. Sweet. And then I'll create one for me too, just so we can see some examples. All right. And you'll notice me inserting stuff doesn't really change the schema because the schema is just a high level view. However, if I now do a select star from people, dang it, semicolon, still forget. We have 2 here. And you'll notice in people, I didn't put the auto increment, but it's still able to increment 1, 2 from there.
I have a quick question.
Yeah.
So I know, like, is there a way to, so that when you're doing that select all from people, like returning the table so it shows like what the headers are for each section and making it look a little
Ooh.
nicer?
You might have to customize some things within the SQLite gem here. I do not know off the top of my head. Yeah, so that might be some research that we'll have to do after.
I think I have it if you want it.
Sweet. Send that
Send
over.
it.
Cool. Yeah, send it. You can add it to Slack.
Cool.
All right. Yeah, it's like I'm not used to running this fully on the terminal, which is why I don't have knowledge of like all the stuff. But yeah. Sweet. So we've done some creates. We've done some inserts. So we did like insert into people. We have a select. Now going off of the select star, what does the star mean here? Does anyone have an idea?
It's a wild card, and it just means like show everything.
Yeah, so this is saying select everything, all of the columns. So typically if you just are trying to read from your table and you want all of the data, this is what you're gonna look for. I always like to go off on like a mini little tangent here. Does anybody know like Hitchhiker's Guide to the Galaxy? I know people who have been here before, you already know this, but does anyone know why the answer to everything is the number, was it 42? 42? Any thoughts?
Is this something with binary?
Close. Closer to binary. However, yeah, so I can like let you know. It is sort of a decoding of the number 42, but not related to the binary representation of 42. It's related to the ASCII representation of 42. So if you look at ASCII value chars, I have to look at what the chart is going to return. But before everything gets converted into binary, and you'll kind of get more knowledge of this as you do like more number conversions, our characters get converted into ASCII values. And every single character is represented as a specific value when the computer interprets it. So the asterisk is 42. So when the computer's like, the answer to the universe is 42, it's meaning it could be anything you want, which is great. It's great.
All these years, I just wondered why they picked 42.
Now you know. It's beautiful. Yes,
That's
sorry.
worth the price of admission.
It's great.
$12,000.
That is the answer to life. All right, so slight tangent, but it's super cool. I love it. But yeah, select everything typically means we're selecting all of the columns and all of the data that we want to see from that table. You'll notice there's a pattern that's emerging from the SQL queries that are writing. In the beginning, we see the operation, so create table, insert, select. That's always going to be the case for any query. And in this case, when you're doing a select, typically you're going to write down all of the columns that you want to and the table information. Whereas inside of our create table, we have our operation and the table name, and create table is a little bit different because we have to put the columns that we want to create to. So start recognizing these patterns because it'll guide you to kind of figure out what query you need to write and what information you need to have or pass in order to write that query. All right, any questions so far? Sweet. And what I want to, what was that?
Sorry, so the argument right after select is the columns that we're selecting.
Yes. So select will always need the columns we're selecting. So you at least need the asterisk there if you just want the default, get everything.
Does the show tables command not work in SQLite?
I think it might. What is show tables? Is it just?
It just returns all the tables that you have.
Is it show tables like this?
Yeah.
Semicolon? No, I'd have to look up specifically what's SQLite.
Hot tables is the command in SQLite to show tables. Yep.
Cool. Thank you. All right. Oh wait, let me go back to VS Code. Sweet. So took a look at tables, what that's going to look like. Columns are always going to be specific columns or values inside of that table. So inside our case, we have our column for 1, which represents the primary key, and then whatever we want to define for the person itself. So we just have name for people, which is fine. The main thing I want to point out for columns is each table, so for columns, we will typically always have a primary key inside of the table itself. So tables are always going to come, when we're defining columns, it's going to at least have a primary key. We'll talk about exceptions like later this week. But if you take a look at the join table, if the join table is just storing the relationship between the two, it typically doesn't always need to have that primary key. So that's like the one exception, because for a join table, you might not need to. But typically, every single table you create is going to have that primary key there. And rows,
If it doesn't have the,
oh, go ahead.
oh, sorry. I was going to say, if it doesn't have the primary key and you want to select that area or that row, would you have to say like select from each value with like whatever responds to these two values?
Yep.
Okay.
And that's where you can kind of dive deeper into relationships, because if you're storing a relationship between two objects, you can't store that instance twice. Like if someone buys something, they can't buy the same object twice. It can only happen once. So that's why those rows end up being unique anyways, and you don't always need that primary key there. It ends up being extra data that you're storing. Yeah, that's a good question. All right, and for rows, typically going to represent each data point inside of our table. So rows are where our actual data in our table is, where our actual data inside of our table is. Cool. And let's create our hikes. So we have all of our stuff. So we have mountains, we have people, and for hikes, I'm gonna do create table, hikes, and ID, integer, primary key, and let's see, hikes has a name, which is text, and it has a mountain ID, which is integer, and person ID, which is also an integer. I hope I spelled all that right. I'm gonna say yes. So this is what our hikes table looks like. We have our ID, name, mountain ID, person ID. You can set up references for foreign keys inside of the table itself. 99% of the time, this is going to be enough to set up your foreign keys. Your foreign key convention that I want to establish now is it's always going to be the table instance that you're looking at underscore ID. So this is always going to be mountain underscore ID, and this is always going to be person underscore ID. And in this case, our foreign key in this table matches to the primary key in the mountain or person table. I'll like pause there for any questions. Let me add that here. So we kind of talked about, let me add foreign keys. We'll always have the convention table underscore name, and always reference the foreign key of a different table. And as you start building relationships, in your table itself. You'll notice there's like exceptions here, but this is just the general pattern that we're going to define in the beginning. All right. So far, have an idea of tables and columns and data, how we represent relationships between them. The last thing I kind of want to go over is this concept of CRUD and what CRUD means in the world of data and in the world of our apps. How many of you have heard of the term CRUD regarding databases before? Maybe. All right, see a couple hands. Whoever is raising their hand, what does CRUD stand for?
Create. I can't remember what the rest of it is.
That's
Something
okay.
is something. I think the last one is database.
Database.
Data.
Data.
Is it
What's that?
R
Data.
relational?
Relational. Sorry, I'm just writing this. Relational. You got some ideas.
Update.
Universal.
Update. Universal.
Darn it.
That's okay. So half of these are right, which is super close. When we're talking about CRUD, I do like the terms that were mentioned because they do technically deal with databases. But CRUD is going to represent the operations that you can perform on your database. So that's how we're going to define CRUD. And CRUD stands for create, read, update, and delete.
Delete.
Yeah, unless
Around
that's
4
what someone said and I wrote data. Cool. So we like teamwork. You had most of it there. Create, read, update, and delete. Once you start building out apps and moving forward, CRUD is going to follow you for your rest of your life as a web developer. So get very comfortable with these terms. Every single thing you build in your app is now going to be associated with what is the user going to be able to create, read, update, and delete. You'll notice you can even practice this when you're just browsing a site. Every single action you do, every single click that you do is somehow associated with some kind of operation. You're either creating some data, you're reading some data, updating, or deleting some data. And in our world right now, every single query you write is also going to be classified into one of these categories. And that's what I want you to get comfortable doing when you're writing your SQL queries. So off the top of your head, if you take a look at some of the queries you've written, where would you classify? First, we wrote create table. Where would create table go in here?
Create.
Yeah, so this is going to be a create table.
Delete.
You can also delete. What's the delete for deleting a table?
Drop.
Drop.
Yeah, so you say like drop table, da da da. What about select? Where's select gonna go?
Read.
Update.
Read.
Depends what you want to do.
Yeah, depending on what you want to do. Typically select, it's not going to make any changes to the table. It's just going to see what data is there and return it back to us. So select is typically going to be a read. And there's a couple different kind of selects you can do. You can like say select everything, or you can be a little bit more intentional and say select maybe like some columns. Or you can say select everything. Yeah, select everything where like some column name equals. So you can get super creative with your selects, but all of your selects are going to be a read, no matter what format it's going to be in, because you're reading information in the table and returning it back to you. Any other queries that you've seen?
Alter.
Insert.
Ooh, I heard a couple. What was that?
Insert.
Yeah, insert into. What do you think insert is?
Update.
Used to add new
Update.
rows to a table.
Yeah, so it could technically be classified between update and create. For insert, the keyword that I heard there was adding new information. So anytime you're creating new data or adding information to your database, it's going to be classified as a create. So insert into is going to be a create. And then I think update is literally just update. So you can like update table,
What about like
And then
order by?
order by, depending on how you use it, it's going to be under the category of select. Because typically you're going to select some information and order that information in some format to be returned to you.
Okay.
Yeah.
What's the difference between insert and update?
So insert is whenever you're creating new information and putting it inside that table. So if I'm inserting a new row, in my case, when I cleared it out. When I inserted Daniel's name and my name into the database, that's an insert. Update is if I'm taking data that's already there and changing it in some way. So the row already exists, but I'm changing a column value, or maybe I'm just replacing the whole thing, still going to be an update. That's a good question. We are inserting new information.
Would alter be create as well?
So alter will technically be an update, because what alter typically does is it takes in a column or data that's already there and it changes it. So that'll be an update. Although technically there is alter table add column, so that could be like 50-50. Like that could be debated a little bit. I think add column is still going to be an update because the table is already there, but you're adding a column on top. So there could be some like slight changes. And then there's also delete, maybe like everything from where, ... So I'm not writing the whole query, just kind of giving you a general idea of what they are. I would say if you're comfortable with create table, you're comfortable with insert, and you're comfortable with a select, update some alter table queries out there, like adding a column, removing a column, and drop table. So if you're comfortable with these like general 8 queries that we have here and how to write them, you are good to go for SQL. The rest of the other like fancy, more like complex SQL queries that are out there, you don't have to worry about them too much. I would say get comfortable implementing CRUD with these queries.
You know why deleting a row or adding a row to your table in SQLite is harder?
Why it's harder? Is that what it was?
I think it was adding a new row to your table. Because I'm reading the documentation on learn.co, it says that if you want to learn how to add a new row, there's some extra documentation because it's more challenging, apparently, SQLite than in SQL or MySQL or Postgres.
Yeah, it said like add a table. It's like don't even worry about it. Just make a new table.
Oh, altering a table. Is that what you mean?
Yeah, by adding a new row to the table, sure.
Gotcha. I think row is typically when you're inserting new rows. I think altering to add a column is what's complicated. Yeah. Okay, cool. Yeah, I was hearing rows and adding a row is insert. Yes, altering columns with SQLite is super difficult because it doesn't have a query that's available to us to just alter an existing column. Yeah. The way that you have to do it is, yeah, it's kind of painful because you have to technically remove a column and then add it after that.
So basically, make sure you get your design right at the start.
Yes. If you're trying to do it with raw SQL, it's going to be very difficult, but I will give you hope. Once we introduce our active record framework, you will have a way to alter your table because it will do the work for us. It'll do the complex work for us. So even if we make a mistake, there's a way to fix it. So there is hope. We will eventually be able to do it, just not in raw SQLite or SQLite 3. Sweet. Yeah, that's a good question. Any other questions? Let me keep track of time because I lost track of time. Da-da-da. Oh, okay. That is we're almost at the end of lecture. I'm sorry, I forgot to take breaks in between. But I'll start to kind of close up here. This was just to kind of give you an introduction of how to work with databases, why we need databases, get comfortable writing queries, and give an introduction to CRUD. So start getting comfortable with just how to do create, read, update, and delete inside of a database, because that's primarily what you're going to be doing over the next couple of days. And the concept of create, read, update, and delete, though, is going to follow you forever, because all of your apps you're going to build out is going to be some form of this. I do want to preface this by saying in the SQLite labs, this is where we get to a point where the amount of labs that we release, it's not going to be possible to complete all of them because we're going to move at a fast rate. We're going to release more labs later today. That's going to connect SQLite and Ruby together. And then the day after that, we're going to introduce a completely new framework that's going to do all of that work for us. So I want to give a heads up that you're not potentially going to get through all of these labs by the end of Mod 1. So keep that in mind. Typically, you just need to get to basic SQL queries. I think students make it to through the Bear Organizer lab. And the next section, it's going to talk about relationship between tables. So if we have, how can you actually use the foreign keys to find common data, which we'll go over tomorrow. But I wanted to kind of give you a heads up. Don't focus on getting all of the labs done. Focus on getting comfortable with CRUD and implementing these 4 queries that we've kind of outlined and that we've talked about. Any questions? All right, I'll kind of put a stopping point there. That was our intro to SQL. And let's take a break for half an hour. If you need that half an hour to just step away from the computer, please do. If you want to just hang out, work on labs, I'll open up breakout rooms again. And we'll meet back at 4:30, and I'll be going over object-oriented design and relationships and objects in Ruby again. So I'll just build out a class from scratch, or I'll have a template of some objects built out. And I want to go over like pry and how classes can communicate with each other. So we'll start kind of diving into that and doing some review. And of course, I'll answer any questions that you have about anything we've learned since day 1. All right, stop recording.